This Unreal Engine 5.5 demo fires 12 projectiles, but creates only 6 projectile actors. The first 6 shots activate 6 prewarmed slots. Shots 7 through 12 wrap back to the same objects, reset them, and send them out again in green. No new projectile actor is spawned during the firing sequence. In this lesson, we will build a fixed pool, store stable object references, choose slots with modulo arithmetic, separate activation from construction, return objects to an inactive state, and verify 6 unique actors, 12 shots, and 6 real reuses with native frames, exact runtime logs, and automation. A straightforward weapon can spawn actor for every shot and destroy every projectile later. That is often completely acceptable. But high-frequency spawning can create allocation work, constructor work, registration work, and garbage collection pressure at inconvenient moments. Object pooling changes the lifetime model. Create a bounded set during setup, keep those actors alive, and toggle gameplay state repeatedly. Pooling is not automatically faster for every game. It is a deliberate trade-off for frequently reused, predictable objects such as bullets, impact markers, enemy waves, or temporary visual effects. The manager reserves space for 6 projectile references. During begin play, one loop spawns exactly 6 A-pooled projectile actors. Each receives a slot index and a home position in the visible rack. After initialization, the pool array keeps the same 6 references for the entire sequence. This demo intentionally logs every actor name at creation and at every shot. That gives us stronger evidence than a counter alone. Pooled projectile actor 0 through 5 are the only identities that ever fire. Returning to the pool does not destroy the actor. The projectile clears its active flag, elapsed time, and velocity, moves back to its home slot, disables tick, and changes to the idle blue visual. A production pool may also disable collision, particle systems, audio, replication, or visibility. The important rule is to define inactive state explicitly. Anything not reset can leak from the previous use, including timers, owners, damage values, delegates, trails, and component state. This bounded demo chooses a slot with shot index modulo pool size. Shot 0 maps to slot 0, shot 5 to slot 5, shot 6 wraps to slot 0, and shot 11 wraps to slot 5. Modulo makes the reuse pattern easy to teach and test. A real pool often searches for an inactive object first, expands up to a maximum, rejects acquisition, or reclaims the oldest active item. The acquisition policy should match gameplay rather than being hidden inside the projectile itself. Activate projectile increments the slot's activation count, resets elapsed time, sets a new start location and velocity, enables tick, and updates the color. First use is orange, reuse is green. The same actor can even be reclaimed while active because activation fully resets its transient state. Notice the separation. Construction creates components and materials once. Initialization assigns the stable slot. Activation starts one gameplay use and return to pool ends that use. That life cycle is the core of the pattern. These are real game mode captures from Object Pool Demo Map. The ready frame shows 6 blue objects parked in stable slots, with 0 shots and 0 reuse. During firing, 5 orange projectiles are moving and the pool size is still 6. The final frame reports 12 shots and 6 reuses. Green projectiles are the second activation of the same slots. The manager, the visible slot labels, and the logs all agree that capacity never increased. Automation checks the configured pool size, total shots, fire interval, inactive projectile defaults, slot wrapping, and expected reuse count. Runtime then records the 6 created identities and every acquisition. Shots 1 through 6 report reused false. Shots 7 through 12 report reused true for slots 0 through 5. The completion gate requires pool size 6, unique actors 6, shots fired 12, reuse count 6, and valid true. The test passed with 1 success and 0 failures. The reusable pattern has 4 stages. Prewarm a bounded set. Acquire 1 available slot. Reset every piece of transient state before activation. Return the object to a defined inactive state when its use ends. Keep pool ownership and acquisition policy in a manager, while each pooled class owns activation and reset behavior. Test capacity, identity, state cleanup, and exhaustion behavior. Most importantly, profile before and after. Pooling adds lifetime complexity, so use it when predictable reuse is worth that complexity, not as a default replacement for spawn actor.